All right, if you look at example 6, there's one other type of domain I want you to be worried about at this point. This is a domain based on physical characteristics of the problem. Okay? If you look at the domain of this is the area of a square is equal to side squared. I think we can all agree that's the area formula for a square, right? You can also do length times width because it's a rectangle, but if you want to get really specific, side times itself is the area of a square. So if I have some square, here's my square, and I know the length of a side, this has to be the same side, side times side equals side squared. There's my area formula, right? Give me a number out there that you can't square. 3 squared is 9. Try again. I'm not saying you can't, like, mathematically. I'm saying that it's not. You're not allowed to square it. Like if you squared it, a black hole would open up at the center of this classroom, swallow us all up, and we would be done. What? 0 squared equals 0. 5. What? 5i. 5i squared. Well, keep it real. Real numbers. We're staying again right now for the sake of this. Say again. Well, we're not square rooting anything. We're squaring. So
I know. Can't square like any number.
you can, exactly. You can square any number. Exactly. Thank you. I didn't hear the whole sentence. Okay. So this function itself would have absolutely no restriction to it. I can square anything. 5 squared is 25, negative 5 squared is 25, 0 squared is 0, 1 squared is 1. But S represents the length of the side of this square, right? The square has to exist. Okay, what's the smallest value S could possibly take on? Or if we even go into decimals, 0.000001, right? Just really tiny square, but in order to be a square, S has to be bigger than 0, right? So that's a physical characteristic that creates a domain, all right? So I know that S must be greater than 0 because I know how a square works. Okay? There's no mathematical reason why this function itself should have this domain, but the fact that what S represents is a geometric shape, a side on the shape. Sides must have positive length, so we must have a side greater than 0 because of that property. And this is domain is the set of all S such that S is greater than 0 would be what I write for this one. That doesn't show up except for in this specific homework assignment. I don't put it on a quiz, but just know that there's rules beyond just mathematical rules as to why a domain happens.